Hello, our most valued student. My name is Confident and welcome to a revision session for organic chemistry. And in this section, I am bringing you one of the prelim papers. I think this is for Gauteng, and it was written, I think, last year. This is for Gauteng. And if you look at question here that I'm going to look at is question number 2. We're going to focus, that is 21 marks. We're going to look at question number 3, 17 marks, and question number 4, 14 marks. Now, you can see, guys, that organic chemistry, or you already know, it is a section that you cannot take it for granted. So I will encourage you, pay attention to this video, watch it until the end, because there is some information that can assist you to prepare for that exam that is coming. You cannot afford not to enter that room. Cannot afford to enter that room unprepared, because definitely you will face organic chemistry, and it is a section that is not difficult. At most, you need to get most of your marks in this section. All right, so let's look at this. Question 2, start on a new page. The following types of formula represents organic compounds. Study the table below and answer the questions that follow. So they've given us A to G. 2.1. From the table above, consider compound B. Write down the homologous series to which compound B belongs. So let's look at compound B, and if you look at that compound, you have this as the functional group, meaning it's C carbon double bond, carbon, and then this, and then this. And then what do you call this part type of a compound? This compound, as you can see, this is an ester, all right, because it's R, C, O, and then another R. You see this? So this is an ester. That's what if you picked up, you could see that there is a carboxyl, there's a carbonyl with an oxygen there. It's an ester. The IUPAC name of compound B. Okay, so they are saying you need to name this compound. Now, if it's an ester, you guys need to know how do you go about naming an ester. Remember, in ester you have to identify the alcohol part, and this is the alcohol part. So that's your alcohol. And what about the other one? The other one is your carboxylic acid. All right. So if you are naming this compound, what are you going to call? You start with the alcohol, and you can see it's one carbon, which is methyl, and then the carboxylic acid there is 1, 2, so it's propanoate. It's an ester, so it's alcohol, which is the methyl part, methyl propanoate. Don't forget that, from propane or propanoic acid. This is the propanoic acid part. So this is more like it's coming from methanol. You see, you take methanol, and this one is propanoic acid. All right, propanoic. So I don't want to dive more there. Consider this. 2.2. An alcohol and an acid are heated in the presence of a concentrated sulfuric acid. So there it is. You take the alcohol and an acid. When you mix an alcohol and an acid, you know what is this reaction called? This is esterification. You are heating them in the presence of what? Concentrated sulfuric acid, and that's a what? That is a catalyst there. All right. And then if in compound B, you are still looking at the same compound. Yeah. This compound B. Let me remove that and say this is still our compound B. Then they are saying here, the role, I write down the role of the sulfuric acid, and we said this is a what? This is a catalyst. That's the simple one there that you can put. Nothing much. Or you can say it is to speed up the reaction. You can talk about the function of it, to speed up the reaction. Right? That's the function of a catalyst in there. And then what else? Names of the alcohol and organic acid used to prepare compound B. We just named them. We said the alcohol, this part of the alcohol. No, I'm doing it wrong. It cuts there. This is the alcohol, the methanol, and what about the acid? The acid there, this is propanoic acid. Propanoic acid, carboxylic acid. Alright, so that is that part. And then the next one, they're saying name of the type of reaction taking place. That reaction, as we just said, when you mix an alcohol and an acid, is called esterification. Esterification, right? So that is that, guys. Let's continue. I think I need to go to the next page. Now look at this. We are continuing. Still on the same question. It says from the table above, consider compound B. So I'll have to be going back. Let me remove that to these compounds. It said from the table above, consider what? Compound C. Let's look at compound C. There it is, and you can see the functional group quickly. There is the one at the end. See, so it's more like you've got RCOOH. This is a carboxylic. So what are they saying here? Write down the name of the functional group. There it is, the functional group there. It's a carboxylic acid. Carboxylic acid. Alright. So that's a carboxylic acid. And then to which homologous series does compound C belong? Okay, the name of the functional group. Okay, that was tricky. It says write down the name of the functional group, and then at the same time to say to which homologous group does compound C belong. It belongs to carboxylic. Actually, the answer is here. That's why maybe they brought it carboxylic acid. And here they wanted the functional group. I mustn't say carboxylic acid. I must say what? It's not far. But the way you write it, you don't say carboxylic. The functional group is called the carboxyl group. Right? This one, COOH. That is called the carboxyl group. The carboxyl group, some they'll say. The carboxyl group. Whatever I call it. Now it says differentiate between the terms functional group. Okay. So that's where now they are catching me here. You see, they say it here, write down the functional group. I said the same, I said carboxylic acid. Now they're also saying here the homologous series. Then they come now and say, show us that you understand the difference between the terms functional group and what? And homologous series. So now what will I define a functional group as? If you are defining a functional group, what do you think, guys? How will you define? Just check your book. Very important for you to go through that exam knowing. But a functional group, we can define it as what? As an atom. It can be an atom or group of atoms. Remember, it can be one atom or group of atoms or a bond. It can be a bond. Okay, an atom or group of atoms or a bond in an organic compound, right? In an organic compound, that what does it do? How does it affect that organic compound? That gives, see, the organic compound its characteristics. What? The organic compound, its characteristic physical and chemical properties. Chemical properties is the one that determines the chemical properties of an organic compound. So it can be an atom. Can be an atom. Can be a group of atoms. It can be even a bond. Remember, single bond, double bond, single bond, double bond, and triple bond. These are different functional groups. It can be an atom like Cl. It can be a group of atoms like OH. It's a group of atoms. Alcohols here, these are halides. These are alcohols. These are triple bond, double bond. These are all that. That's why I'm saying atom, group of atoms, or bond. in an organic compound that gives the organic compound its characteristics, physical or chemical properties. And then what about a homologous series? You need to know also a homologous series here. Guys, as I say, but the best I can say, go to your book, homologous series. You need to master this. You just give a definition of this. That's what they want. When you're giving us the definition, you're telling us the differentiation. Now, a homologous series, it is a series or a family. This is now a series, or some can say it's a family of what? Of organic compounds. It's a series or family of organic compounds having the same molecular formula. These compounds have the same molecular formula, and let me say by and one what, and I want to say it nice properly here, and one compound differs, that's where usually they want to check there, differs from the next compound. Alright, so and one compound differs from the next compound by the addition, of the what? By the addition of the CH2 group. That's the main part. A series or family of organic compounds having the same molecular formula, and one compound differs from the next compound by the addition of the CH2 group. So guys, that was very important for you to, as I say, textbook will work here, 2 marks. From the table above, consider compounds A, D, F. Let's look at them. We have got A. Let me take this off now. So I have got A here. They said I must consider A, I must consider D, and I must consider F. But now something is already showing me. What is it? Look at this. OH, propanol. You see, there's an alcohol there. And then they are saying, write down the homologous series to which they belong. They belong to alcohols. Compound A and D are isomers. What type of isomer will they be classified? A and D. Let's look at A. So A, the OH is in the center, and D, the OH. You see, if you have to quickly draw D, you will have this C. Are you seeing that? 3, and then this one, the OH is in carbon number 2. This one is in the end. So what we call this? We call these positional, the position of the functional group. So we call them positional isomers. Remember guys, there are 3 types of isomers. What are those? We have got number 1, the functional isomer. And then you have got number 2, the positional isomer. And number 3, what type of isomer is? There is the functional isomer, where the functional group is different. Then we've got the positional isomer. I forgot that third one. Sorry about that. But there are 3 types of isomers. Just you can remember. My mind is just trying to find out what is the third one. Functional, positional, and structural isomer. Functional, positional, and chain. I think I'm forgetting this. Chain isomer, I think so, but I will check that. Guys, please. Okay, let's not do this here. Alright, but just know that you need to know this 3 isomer. And then it says draw the structural formula of compound F. Compound F, let's look at that. Structural formula of compound F. There is F. Now it says 2-methyl propane 2-ol. The key word, the longest chain is propane. 3. Prop means 3. 1, 2, 3. Are you with me? So now with 3, but it says, I just want to bring this so that I've got enough space here. Look at this. I have got propan-2-ol. So in couple number 2, because this one 2, I've got OH. So please be careful how you do your OH there. Don't do it like this. Don't say OH like this. They'll penalize you because they say it's structural formula. Alright, so you must show the bonds between the oxygen and the hydrogen. And then here, 2-methyl, again in couple number 2, you have got a methyl like this. So that's it. Right, then you fill the rest with the hydrogens. That one there, that one there, and that one there. And then you fill the rest with hydrogens. Remember, the carbon must have how many bonds? A maximum of 4 bonds. Minimum is 4 bonds. So then you become correct like that. 2, carbon number 2, there is the methyl. In carbon number 2, there is the alcohol propanol. Alright. Let's move on to the next one. Write down, still on question 7. Okay, last 2 now. Write down the IUPAC name of compound G. Now, 3 marks. Let's go there. IUPAC name of compound G. Let me erase this. Look at compound G. Now, with compound G also, you need to study it. What is the longest chain? The longest chain, I can start from here. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. It doesn't matter, go up, down, or same is carbon 6. It will give me higher. So carbon 6 is more from an alkane, so it's hexane. 6 is hexane. But look, in carbon number 2, what do I have? I've got a branch here. There it is. We call it 2-bromo. And then in carbon number 5, there is a branch. There is a branch. What do we call it? Carbon number 5, this is a methyl. This is another methyl. So if there are 2, what do you call them? It's in carbon number 5. You see 5 and then 5 hyphen is 5-methyl. So we call it di. Now methyl, M starts before D. B starts bromo, B before M. So you'll have here 2 bromo. There mustn't be space between bromo. Here 2 bromo. Let me remove hexane for now. So it's 2 bromo. Let's go to 5. So you put what? 2 bromo. Then hyphen, because the number and the letter, it's 5, comma, 5, numbers and the numbers. So it's in carbon number 5 there's a methyl, again in carbon number 5 there's a methyl. And then hyphen, remember there are 2 of them, is dimethyl. Dimethyl, meaning there are 2. Dimethyl what? Hexane, no space now, hexane. That is one way you could have done it. But look at this. I don't want to erase much there. What about if I rename my carbon atoms? I want to rename them, and when I'm renaming them, these numbers will also change. So when I'm renaming them, I'm starting now from right to left. This is my carbon 1. This becomes my carbon 2, my carbon 3, my carbon 4, 5, 6. I encourage you always do that. Go one direction, go the backward direction. So now you see it's carbon 2 now. It's carbon 2 and this bromo is in carbon 5. So what will be the name now? It will be 5 bromo. We maintain the same way of naming, but now remember B starts before what? Before M. But in carbon number 2 is 2, 2 dimethyl hexane. Now from the 2, which one are you going to take? You take the one with the lowest numbering. Obviously, you can see that this one goes off because 5, 5, 2. If you add 5 plus 5 is 10 plus 2, this becomes 12. But 5 plus 2 plus 2, it becomes 9. This becomes the answer. Scratch off that one. It's off. So what is the answer? 5 bromo 2, 2 dimethyl hexane. Remember that. That is IUPAC naming. Now the last one says the structural formula of compound E. Let me see compound E. Alright, so let me use the same space here that I was working on here to do compound E. Structural formula is similar. What do you do? 2, 4 dimethyl. So there are 2 of them. Pent, 1 in pent. The longest structure pent is what? 5. So it's 1, 2, 3, 4, 5. So pent 1 in carbon number 1. I I want to start from left to right. There is my pent 1N. Then when you do that, this hydrogen sometimes faces like this. I prefer it like this. But sometimes it's fine to do it like this. It's still okay. If you want to, you do it at 90 degrees like this. You do your hydrogen, it's still fine. Even if you do it in that way, but the proper way to me is that other first one. Alright, and then 2 in carbon number 2. So this is my carbon 1 and carbon 2 and carbon 3 and carbon 4, because my double bond is the one that is telling me how to number them. So I don't want to number them when I'm writing, so you saw that. So in carbon 1, number 1, 2, what do I have? Methyl. So I've got C, H, H, H. There is the methyl. And then in carbon number 4, so 1, 2, 3, 4. Here again, let me do it down this time. I have a methyl there. That's it. It's done. So what did they say? 2,4-dimethyl pent 1N. The pent 1N is there. The methyl, these are there. That was the main thing. Then you fill up with what? With the hydrogens. So remember, a carbon must carry 4 bonds. So the first carbon 1 is 1. Let's look at this one. Carbon 1 is 1, 2, 3, 4. It's done. If in carbon 2 there is a bond 1, 2, 3, 4. It's done. Then the only one left is the other carbon. This one already is 1, 2, 3, 4. This one 1, 2, 3. It needs 4. The end also needs 1, 2, 3, and 4. That becomes the structure of that. Alright, so that was this question. 21 marks, guys. This is where you need to maximize. Please, almost everything you must get it right there. Let's go on to the next one. The next question, question 3. It says study the following two organic structures and answer the questions that follow. Alright, 3.1.1. Compound A and B are functional isomers. You see, they are bringing that functionality. Remember, I said 3 types of isomers. The functional isomer, this what do you call this? The chain isomer, I think is the chain isomer, yes. And then positional isomer. So here they gave me functional, meaning there is different functional groups. Look at this one. What is this? This is an aldehyde. Aldehyde. It's carbonyl, but this one is what? What did you say? What is it, guys? Tell me. What is it? Yes, you're right. It's a ketone. So you see, compound A and B define the term functional isomers. What is a functional isomer? The key word they wanted there is to say same molecular formula, like describing an isomer. Remember, an isomer is an organic compound with the same molecular formula but different structural formula. So you maintain the same way, same molecular formula, but now because they are specific to say functional formula, functional isomer, they say but different what? Functional groups. See, that's why it's called functional isomer. Functional groups. So it's a compound with the same molecular formula but different functional groups. And then it says write down the IUPAC name of compound. Write down the IUPAC name of what? Of compound B. Now let's look at this. What is compound B? It's a ketone. So what will we call compound B? If it's a ketone, how many carbons? 1, 2, 3, 4, 5. It's 5 carbons. So 5 is what? Pentanone. Ketone are like this. Pentane, but it's pentane 1. You see? It's pentane. Where there is E, you put 1. But now, when you're writing it, it's up to you how you want to write it. The simpler way, but it's not the most preferred way, is pentanone or pentane 1, pentanone, but you look at the carbon. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Even if that is this naming. If you go this direction, it doesn't change. It's 1, 2, 3. So you see the functional group is in carbon 3. So you just say 3 pentanone. That's it. But if you want to write it the right way, it's pentane and then pentane 3, 1. See the thing. So how do you see? So you write pent. Remember the name change, pentanone, penten 1. There it is. If you combine these two, look, if I bring this together, it's penten 1. But I pull it aside, and then in there I indicate that in carbon 3, that's where you find that carbonyl. That's a carbonyl group that determines the ketone. Then you put hyphen because a letter and a number, and the letter and the number is separated by that. This is the preferred one, but they will also mark you there. They need to mark you there. Okay, write down the IUPAC name of compound B. How does the boiling point of compound A, let's just erase again here so that we can have this. So they're saying what? How does the boiling point of compound A, this one, compare to that of pentanol? Okay, pentanol. If I'm to draw pentanol will look like this. Similar. It's 1, 2, 3, 4, 5. So you'll have it similar like that, but here you'll have OH. That's all. Everything is hydrogen. It's the same. So, but they're saying how does the boiling point? There's what? You write here greater than or equal to or lower than. Now, pentanol, how does the boiling point of A compare to that of pentanol? A will have a lower boiling point than pentanol. It's smaller. So the answer is lower. A has a lower boiling point, meaning pentanol, this one has a what? This one has a higher boiling point. BP, boiling point. Pentanol. And then says, explain your answer in question 3.1.3. That answer we just wrote. Fully, says be full there. You need 3 marks. By referring to the type of intermolecular forces present in each of these compounds. So guys, how do you go about this one? I want you to be very sensitive in 3.1.4. You want 4 marks, right? Now they say explain fully by referring to the type. Listen to the question carefully. Type of intermolecular forces present in each of these compounds. So tell us what forces are having. So you say compound A. Remember, it's an aldehyde. You can say the aldehyde, or you can refer it as compound A. So what type of intermolecular force are there? Now compound A has only what? What do you think? There are no hydrogen bonds here. You can see that it's only what? Van der Waals forces. Okay, it's the Van der Waals, or you can even tell us that they have only weak Van der Waals forces, right? But you can be specific even here of the Van der Waals forces. These are dipole because of the carbonyl group. Okay, the dipole forces, right? So compound A has only dipole forces, if you want, or Van der Waals forces. And then what about compound B? I mean, not compound B. What do they call it? Pentanol. But then you tell us what about pentanol. Number 1. Number 2, pentanol has both the Van der Waals forces. You can maintain them like that. Van der Waals forces. It's better to write in point form. And thus they have both the weak, I like to say weak, and the strong hydrogen bonds. That's where they wanted to see the difference now. Hydrogen bonds. Remember we said it has a higher boiling point. It's because of these hydrogen bonds and strong hydrogen bonds. Now we have, these are the molecular forces. They say refer to the intermolecular forces present. We have shown them. Now explain now, what does this mean? Compound A, weak Van der Waals forces. Compound B, extra hydrogen bonds. Then you conclude to say more energy is needed or required, is needed to break the hydrogen bonds. More energy is needed to break the hydrogen bonds in what? In pentanol. Then therefore or hence a higher boiling point. Avoid saying BP, I'm just even avoiding it. Higher boiling point. That's what they wanted to capture in this. Alright. Now how will the vapor pressure, now we're moving on to the 1.5. How will the vapor pressure of compound B compare to that of pentanol? We're back again. Compound B. Look at compound B. There it is. Now they're asking about vapor pressure. Which one is a vapor which one is vapor pressure, meaning which one has a higher boiling point in a way? Which one is easily a gas? The pressure, the vapor pressure, which one is easily in vapor form? Pentanol and compound B. So you can see this one has a higher vapor pressure. It's B. So they are saying here, how does the vapor pressure of compound B compare to that of, right? Only higher than, lower than. It is higher than the vapor pressure of B. B has a lower boiling point. And then fully explain your answer. Again, you can use this scenario, this one on top here, to say it's linked to the intermolecular forces. So you come here on 3.1.5. Then I can even come here and say, I'm changing this question now to 3.1.5. You see? You'll see how I can change that. 3.1.5. But now I'm using compound B, not A. So I'll say compound B is only weak van der Waals forces, dipole is still relevant because of this CO, right? And then what about compound A? I mean pentanol is still the same. Pentanol has both the weak van der Waals forces and the strong hydrogen bonds. And then I can then come here. I can even use this, but I can change here. Remember, I'm now focusing on compound B. Then I can say as a change, less energy is needed to break the bonds. Now, to break the bonds in compound B. Less energy is needed to break the bond in compound B, hence it has a lower boiling point or higher vapor pressure. Just to show that you know that boiling point and vapor pressure is inverse. The lower the boiling point, the higher the vapor pressure. Alright, that's it. You see, nothing changed here. It says learners use compound C to E to investigate one factor which influences the boiling points of organic compound. One factor, I think that's the third. No, I'm wrong. Okay, yeah. Remember the isomer chain, I think chain isomer. Learners use compound C to E. There is the change in chain. Look at it. Compound C 1, 2, 3, 4. Then D 1, 2, 3, 4, 5. And then E 1, 2, 3, 4, 5, 6. These are alkanes, as you can see. So butane, pentane, and hexane. Look at the boiling point from negative to 36 to 69. Now define the term boiling point. Okay, what is a boiling point? Boiling point, it is the temperature at which the vapor pressure, you link that word, the vapor pressure of a what? Of a compound is equal to, what can I say, is equal to the atmospheric pressure, to the atmospheric pressure. It is the what? The temperature at which the vapor pressure of a compound is equal to the atmospheric pressure. That temperature where a compound exists in a gaseous form, that's why we say the atmospheric pressure is the vapor, is the boiling point. But listen guys, definitions, I'll always put a star and saying I might not capture everything correct, but you need to check the book. Okay, write down the independent variable of this investigation. Remember what we have here. If you look at this table, it's divided into like here. What are we changing here is the chain length here. Chain length here, and this other side is temperature. If you're putting this as the columns, like here, you see, so you've got chain length, or instead of chain length, you can even use other words there. It can be chain length, or it can be molecular formula, or molecular mass. The mass is changing, or it can be here the surface area, SA, surface area, molecular mass, chain length, molecular mass, molecular formula, and then number of carbon atoms. You can use number of carbon atoms, because you see we're changing from 4, 5, 6, and then now they're saying which one of the two here. Independent, what are you changing? Remember, the independent is what you are changing. What are you changing? You're changing what? The type of compounds, the chain length. So here the independent is the chain length. That's what you must write there, chain length. Alright, write down the type of the van der Waals forces that occurs between these organic compounds. Alkanes, guys, what do you have? You've got it's more like London forces there, because these are symmetrical compounds. These London forces, sometimes the London forces, you call them what? The dispersion forces. Dispersion forces, or you can use the word induced. Remember, it's temporal dipoles. Induced dipole. Induced dipole forces. Whatever case, but mainly it's London forces, or dispersion, or induced dipole forces. Write down the conclusion that can be drawn about the boiling point of straight chain alkanes. How many marks are these things? One. Okay, this is 2. What conclusion about the boiling point of straight chain alkanes? You can see that the boiling point is increasing, going down. You see, it's increasing. So you can say the longer conclusion, the longer the chain length. What is the conclusion? The longer the chain length, the higher the boiling point. Or boiling point increases as the chain length increases. Anything, and you say the boiling point is dependent on the increase in the chain length. Anything there. Alright, guys, 17 marks. I need to wrap this up. Now let's look at the next one. Last question of this paper. Says most organic compounds can undergo different reactions to produce a variety of organic compounds. Some incomplete reactions are represented below. Okay, I'm not going to study this, but just because of time, let's go straight. 4.1, consider reaction A. Write down the type of reaction that takes place. A, guys, where are we moving from? In A, we are moving from a secondary alcohol. Okay, we'll talk about that. Now, we are moving from an alcohol to an alkene. This is alkene, propene. See, so here you are introducing a double bond, but here it was only what? This was single bond. So do you see that they consider this type of reaction that takes place? This is elimination in simple form. Type of reaction, it's elimination. Because to get an alkene, a double bond from a single bond, you have to eliminate. But the most proper answer there is a type of elimination. Remember, from alcohol to an alkene is dehydration. You're taking out water there. It's a dehydration reaction, to be specific. 1 mark anyway, so it's fine. Reaction B represents a hydration. You see now, when you go up, it's D. When you go down, they're saying hydration. You see? Okay, reaction B represents a hydration reaction. Define the term hydration reaction. It's a reaction that involves what? To hydrate yourself is what? Involves the addition of water. Addition of H2O. but the right word there is, since you're writing, it says the addition of water. Alright, write down the name or formula of the catalyst used in this reaction. Now propene, then you have got an alcohol here. Let me see, if you're adding, okay, write down the name or formula of the catalyst. You know, for hydration, propene to this alcohol, mainly it's sulfuric acid here. Sulfuric acid. We just added an acid, the name or formula of the catalyst. It's sulfuric acid, but you can use this word H2SO4 because they're saying formula. Yeah, this acid, you put an acid here, this thing will become an alcohol. But yeah, these are the reaction conditions. During reaction C, a specific rule, reaction C, let me see, propene HBr to 2-bromopropane. Okay, a specific rule, the Markovnikov rule is followed to determine the measure, whether is the measure and minor product. So during reaction C, a specific rule is followed to determine the major product when HBr is added. Alright, write down 2 conditions for this reaction. See, we're taking propene, it's like this. We are taking here propene to 2-bromo. So when you're adding, this is addition, right? And you are adding there. So what do you need here? What do you need here? Okay, addition reaction in the propene. This is hydrobromination or hydrohalogenation. What are the reaction conditions for hydrohalogenation? Hydrohalogenation, I'll say, have a concentrated, but I'm bound to correction here. I haven't gotten such questions mainly. Concentrated acid catalyst. Let's say that. Concentrated acid catalyst. Another thing here, you need, let's be saying, because I'm just trying to make answers here, it's a strong acid. Remember, there is a weak acid and a strong acid. So number 1 condition is because of HBr, we need a strong acid with it, such as what? Such as phosphoric acid, you see, H3PO4. So you need 1, it must be a strong acid. 2, that acid must be concentrated. I think it will work there. What else? Yeah, strong acid. Or you can say also, because of bromo and strong acid, here you can avoid and say no water. You don't need water. Avoid water because you will end up forming an alcohol there. Alright. And then during reaction C, a specific rule, okay, there. Use structural formula and write down the balanced equation for this reaction. Which one? Reaction C. Okay, let's look at reaction C. Propene. So remember, propene is like this. 1, 2, 3. Propene can't be anywhere than this. It has to be propene. You cannot say 1 propene. So that is this. Plus, what are we adding? HBr. Okay, so please, structural formula HBr, you see, and then what do we get? We are saying 2-bromopropane, so this becomes 1, 2, 3. There you have 2-bromo, and then I'm trying to avoid that error there. That's it. 2-bromopropane, guys. There is the reaction. They said write the balanced reaction there. Please avoid that. It's not part. Okay. So I think you can see that. Alright. So what was the question there? Use structural formula. So that is the structure to write down the balanced equation for this reaction. Is balanced. Nothing was. You are adding this. So it's addition, there is no other product you get. It's balanced. And structure, please, HBr, make sure that it is structural. Alright, so use, okay, now 4.4, identify the type of reaction taking place at reaction D. What is D? D, propane already is an alkane. Okay, sorry about that. It's an alkane. And from an alkane, you go to 2-bromo. So you can see that you're having bromo in that alkane. So it's substitution. Okay, substitution reaction. So that's a substitution reaction. Alkane to bromine, yes, substituting there. And then what about that? Identify the type of reaction taking place at reaction F. Okay, let me remove this, not to confuse. Reaction F is moving this direction, right? So what are we having? 2-bromopropane. I think that, guys. From bromopropane to what? To alcohol. Again, from bromo to alcohol, which is OH, is another substitution there. Substitution. But the right word, whenever you put OH, is called the hydrolysis. That's the proper word there, hydrolysis reaction. But substitution is also correct. Reaction E is a hydrogenation reaction. Reaction E, okay, they tell us propene to propane. Okay, you are adding what? Hydrogen here, H2. Right. Now, what are they saying? Write down the 2 reaction conditions for hydrogenation reaction. Reaction condition. The common one is catalyst. And what is the catalyst? Is platinum. Platinum catalyst. This one is the common one. Platinum catalyst. Sometimes they allow nickel, if you want, or palladium. Nickel or palladium. These are catalysts that you can use for this. But now, what's the other one? Is it high temperature for, hydrogenation? What else will you need? Okay, the non-polar solvent. Very important. Very important. The non-polar solvent. Now, when the moment they say non-polar solvent, the opposite of that is what? No water in a way. Water is polar. It will because you have different things there. So no water, or you can use non-polar solvent. Now this reaction is widely used in industry. Name one use of the hydrogenation reaction in food industry. Is used commonly in the formation of what? You tell me. Formation of what, guys? Come on, guys. Hydrogenation of alkenes. It's margarine. Come on, guys. It's formation of margarine. You need to know this part. It's a common thing. So that is 14 marks. So guys, I was bringing you that organic chemistry as you prepare for your final exams. I hope this will be very useful to you. Give me your comments. Give me your... Yeah, you guys don't just watch without commenting. Tell me, what do you think? Is it beneficial? Did you benefit something? Is there something that you think I could have said or I put it in the wrong way? When you comment with me, it also helps me to improve on the next one so that I can check what you guys are struggling with in a way. But we've come here to the end of the lesson. If you're not subscribed, you are committing a 24-minute lesson crime. It's a crime if you're not subscribed. What type of crime? It's called a 24-minute lesson crime. Why? Because why are you watching without subscribing? This 24-minute lesson needs you to tell 24 minutes that you are watching at the end and continue making these videos because we are benefiting. That's what we are trying to say. Continue making these videos. Why? Because we are benefiting. Don't stop. Don't stop. You know what I'm trying to say. So that's what it does. But if you're not subscribing, it's fine. I can see thousands of students on. You see this YouTube thing. It shows us the metrics or the analytics whereby how many are connecting at any point. You find 2,000-3,000 people connecting at one time, but you guys are not subscribing so that one can tell whether is this beneficial or just wasting your time, you know. But anyway, I wish you all the best in your final exam. This is the 24-minute lesson. My name is Confident. Thank you.